guys, how are you doing tonight? Today we're going to actually talk about polygons in a coordinate plane. So we're going to be talking about graphing them and using coordinate methods to prove what kind of, or to classify the quadrilaterals. So remember when I told you that in college my geometry teacher could tell whose papers were whose proofs were whose based on how they proved. And I said I really liked coordinate methods. So here is where you get to learn what I really like to prove. So we're going to be using the distance formula, the slope formula, and the midpoint formula to classify these triangles. Okay, so you need to make sure you know those. Remember, I don't give them to you on tests or quizzes. You're also going to use the Pythagorean theorem, which we haven't really touched on, but you've learned in the past. Remember that the sides of a right triangle, when I square them, is equal to the hypotenuse squared. So we're going to use that maybe once in the homework. We'll spend a lot more time on the Pythagorean theorem later. So let's stop and think. Some of these are the different ways that I can prove what a quadrilateral is, or prove that something's a parallelogram. If I want to determine that the diagonals bisect each other, remember that means that when they're bisected, whatever it is, we're going to get congruent halves. They're not necessarily congruent to each other, but we're going to get congruent halves. So if I want to determine if diagonals bisect each other, I'm going to use the midpoint formula, because if they have the same midpoint, then they would be bisecting at that point. If I want to decide that opposite sides of a quadrilateral are parallel, I can use the slope formula, because remember, parallel lines have the same slope. If I want to prove that polygons are congruent, I could use pretty much anything. I can use distance. Actually, right now, all you pretty much know is distance. So I'm going to use the distance to prove that polygons are congruent, because I can prove that their sides are congruent. And I might also have to use the slope formula to see, if the angles are the same, congruent, that kind of thing. If I want to know if the diagonals are perpendicular, like in a kite or a rhombus or a square, again, I'm going to use the slope, because slopes of perpendicular lines are opposite reciprocals. So remember that if the slope is 3/4, its opposite reciprocal would be -4/3. All right, so I want to classify this triangle as scalene, isosceles, and equilateral. Now here is where some of you guys are going to have some trouble, because you like to do your work all over the page. Your work, and I'm going to look at it, needs to be very nice and neat, because you're proving something to somebody else, and they need to be able to follow it. So if I want to classify this as scalene, isosceles, or equilateral, those are all side lengths. So I'm going to find the side lengths. So maybe off to the side, I want to say I know that the length of BC is, I know the length of AB is, and I know what the length of AC is. Okay, so BC, we can just count. It's 1, 2, 3, 4, 5, 6. So the length of BC is 6. Now for AC and AB, we're going to have to use the distance formula. I know you love that. Okay. So, or actually, this is where you could use the Pythagorean theorem. If I know that this side here is 1, this side is 1, 2, 3, 4, 5, I can use the Pythagorean theorem, because that is the hypotenuse. Okay? And it's probably easier to remember than the distance formula. So AC squared is going to be 1 squared plus 5 squared. And if you think about it, it really is the distance formula, because the length of the one, well, actually, I'm going to prove that to you at a later date. So AC squared is going to be 1 plus 25. AC squared is going to equal 26. And when I take the square root of both sides, I'm just going to leave it as the square root of 26. Please notice how nice and neat it has, and everything's labeled. So I'm not doing work all over the place, okay? You're not doing this work just for you. You're doing this work to prove to somebody something. All right, and let's then do BA. So I know BEA squared by the Pythagorean theorem. So I've made my right triangle, and this side is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so that's going to be, we don't need the square root yet. Okay, 5 squared plus 5 squared, which is going to be 25 plus 25. So BA squared equals 50, and then when I square root both sides, BA is going to be the square root of 25. So look, all three, or gosh, the square root of 50, all three sides are a different length. So that means that my triangle is scalene. So this is scalene. No sides are congruent. So when you're proving this to me, I want to see this. Okay, so this would kind of be my proof, the final answer, and I want to see this work nice and neat. Don't ask much from you guys. All right, so what I did here is, because you're going to be proving different kinds of quadrilaterals, is just another graphic organizer. You have the one that you're going to fill out that just kind of is a flow chart that starts with a quadrilateral. It's a polygon with 4 sides. And then the trapezoid is a quadrilateral. And then we've got an isosceles trapezoid and a right, which we don't really talk about a right trapezoid. I know a kite, and then the parallelogram and all the others right off from each other. So just kind of a nice way for you to look at those properties. Tons of properties that you have to know. So I'm going to graph the following quadrilateral and classify it. So negative 1, 8 would be point J, and I'm going to label that. 1, 6 would be K. L is negative 5, 0. And M is negative 7, 2. That's 1. So here is my quadrilateral. Now it looks to me like it's a rectangle, so we can do a couple different things to prove that it's a rectangle. We can use our diagonals, because we know, if I go back a slide, that a rectangle, where are you, rectangle? All properties of parallelogram, it has a right angle, and we know our diagonals are congruent. So if we know we can prove our diagonals are congruent, then that's one step in finding the rectangle. And then we can decide if our opposite sides are the same, which we might just want to do that. And then we've got to prove right angles. So actually, let's just go ahead and prove that. Let's go with the diagonals are congruent. Okay, so if I go with my diagonals are congruent, or actually, let's not do that. Let's go with opposite sides are congruent. Okay, so let's go with JK. Okay, so that side there is 2 and 2. So JK squared is equal to 2 squared plus 2 squared. And we can even work across. Well, actually, no, let's not work across. 4 plus 4 is JK squared. And that's going to be 8. And if I take the square root, JK is 8. So the side opposite is ML. So if I make let me change the color ink here. Another, it looks like it's going to be, but you know me, we want to show the math. So it's going to be 2 squared again and 2 squared. And since it's exactly the same, I'm okay with you jumping and saying that it is 8. So right now over here, here's part of our proof. I've got JK is equal to ML, or congruent to ML. Then I've got the other side. So if I go with LK, I know that this side is 1, 2, 3, 4, 5, 6. This side is 1, 2, 3, 4, 5, 6. So LK squared is going to be 6 squared plus 6 squared, or 36 plus 36, which is 72. And if I square root both sides, I'm going to get LK is the square root of 72. Its side opposite is here, MJ. And 1, 2, 3, 4, 5, 6. So 6 squared. And then 1, 2, 3, 4, 5, 6, 6 squared again. So we know that that starts out exactly the same. So we've got that. So right now I have MJ congruent to OK. So I've got opposite sides are congruent. Now I want to prove that those opposite sides are parallel. So to do that, I'm going to find the slope. Slope should be easy because we've drawn the slope triangle. So let's just go with the slope of JK. Notice I'm just putting M and then JK, and that's going to be negative 2 over 2, which is negative 1. If I go with the slope of ML, again, 2 over 2, which is negative 1. So we've got that JK is parallel to ML. And let's check the other sides. We said each of those were 6. So the slope of LK is positive 1. 6 over 6. The slope of MJ is, again, 6 over 6, or 1. So then I've got that MJ is parallel to LK. The nice thing now about using the slopes is we can say that the consecutive sides are perpendicular, which means they have a 90-degree angle. So using that opposite reciprocal, we also have LK is perpendicular to JK. And that's really all we need because of all the properties of parallels to say that this is a right angle, because if these are parallel, they're consecutive inside, interior, so they're going to be parallel. So because of all of this, we can say that JKLM, so parallelogram JKLM, is a rectangle. So it's a lot of work, which is why you don't have a lot of homework problems. Okay, so today you learned how to use algebra and coordinate methods to classify a quadrilateral. We did it using the slope, the midpoint, the distance, and the Pythagorean theorem. So you guys have a great day, and I will see you in class.